Today we're going to be talking about compound inequalities. So the first thing we're going to do is define what is a compound inequality. Much like the word compound implies, it is meaning that an inequality that combines two simple inequalities. So it puts two inequalities together. Now, inequalities could be put together in two different ways, which we will see as we go on through notes. So the first thing we're going to do is we're going to write each sentence as an inequality. And we're going to graph each inequality. So number one, a number A is less than 6 and greater than or equal to -2. A number A is less than 6 and greater than or equal to -2. So let's break it apart. So we have first the number A, or letter A in this case, is less than 6. So A is less than 6. But it also says and greater than or equal to -2. So A is less than 6, but A is also greater than or equal to -2. So two different things are happening at the same time. Let's see what happens when we graph those together. So we have -2 over here. And I'm going to go by 2's because it makes things a little bit easier. And I have A is less than 6. So I have open circle at 6, but A is less than it. So it's going that way. But at the same time, A has to be greater than or equal to -2. So at -2, I have a closed circle, but A is greater than or equal. So how could it be both of these at the same time? Well, what ends up happening is that we have a combination or a compound inequality. And so we're actually going to rewrite this so that it looks more like a compound inequality put together. So to combine, we're going to go down. Okay. So rather than writing it as two separate statements, because it's an and statement, we want them to be put together. What you're going to do is you're going to take the smaller number, which is -2, and you're going to use the inequality sign where it faces towards the variables. So rather than saying A is greater than or equal to -2, I'm going to say -2 is less than or equal to A, right? The same thing, just rewritten. But at the same time, A is less than 6. So I'm going to continue the statement by just saying less than 6. So now I've combined and I have -2 is less than or equal to A, which is less than 6. And this is my combined inequality. Now let's show how we would make a combined graph. Similar to above, we still want to include everything. However, I don't need to show the overlapping. I can just show that it goes from one side where it's or equal to -2, and it goes over to 6 where it's an open answer like that. Now my line is super not straight, but that is my combined answer. So this is kind of how you would start thinking about it, but this is actually the proper answer for how we would answer that. So a number A is less than 6 and greater than -2. So what does that mean my answers are? That means my answers can be anywhere in that range. It could be 0.5, it could be 2, it could be -1, it could be -2. Any of those answers would work. So a number A could be any of those answers within that range. Okay, and that is one example of a compound inequality. Let's look at the next one. Number 2. A number W is at least -3 or at most -6. A number W is at least -3 or it's at most -8. Now we have to think about what those words mean. If we go back to thinking about lesson 4.1, okay, remember when we learn about at most and at least. So if a number W is at least -3, that means it has to be greater than or equal to -3. So at least, you have to be at least this tall, so you can be taller, right? So this would be an option. Or, this one's an or statement, we'll talk about that in a second. Or W is at most -8. At most, meaning less than or equal to -8. So this one's going to be a different kind of compound inequality. It does combine two inequalities, but it keeps them separate at the same time. So they're both happening at the same time, but it's not the same combination as an and. So when we deal with an and, that means both things are combined together and we have both options. At this one, both options work, but they don't work in tangent like the one above. So when we look at how this looks on a graph, let's see. So we have my options. Whoop, there we go. So W is greater than or equal to -3, meaning it's going towards to the right. Or W is less than or equal to -8. And so both answers can be true, but they're working in different options. So that means that W can really be anything except for what's between these values. They're going in opposite directions. So it could go all the way up to 1 million, all the way down to -10 billion. It just can't be these values. So it's either this or that, not an and combination. And so these would be my final answer for this one. Okay. And obviously you don't have to box it. I'm just showing you that rather than using this first method, we want this, but with or, it just is what it is. Okay. So now we're going to do the opposite of this from 1 and 2, and I'm going to draw a graph and you're going to tell me what the inequality should be. So it'll either be a statement where it's an or statement like this, or it'll be an and statement like this. So remember, if it's an and statement, it should be combined together like this. And if it's or, it's separate. Okay. And I'm going to pause the video real quick to draw those in. Okay. So for the next examples, 3 and 4, we're going to write the compound inequality for the graph. So using the graphs from 3 and 4, we're going to write a statement that is a compound inequality. Go ahead and take a second to pause the video and draw in these graphs, and then create what you believe the compound inequality that represents those graphs should be. And I'm going to go ahead and let you try these on your own based on what we did with 1 and 2. Pause here and come back for the answers. Let's see how you did. So on the first one, we have arrows that are going opposite directions. So this should be an automatic message to your head that we have an or statement. So we're just going to write down the separate inequalities and combine it with an or. And you can pick any letter you want. Most commonly, you're going to pick X for your letter. So therefore, we have X is less than -3, or X is greater than or equal to 6. And that would be our answer for number 3. For number 4, let's look at what you got for number 4. So number 4 has a line in between, so that's going to give us a clue that this is an and statement, meaning our variable is going to be in between the two values. So I have -2 is less than or equal to X, which is less than 1. -2 is less than or equal to X, which is less than 1. And hopefully those went well for you. Let's move on to solving compound inequalities. So we're going to solve each compound inequality and graph its solutions. And as always, we are going to show work. So number 5, we have X plus 8 is greater than 9, and X divided by 7 is less than or equal to 1. Okay, and so this is one way an and statement can be written. And essentially what you're going to do is solve it separately, but we're going to combine our answer together because it's an and statement. So the first thing I'm going to do is I'm going to subtract 8 from both sides to simplify X. And I get X is greater than 1. Over here, we have X divided by 7 is less than or equal to 1. So when we have something in the denominator, we're going to multiply by that value to both sides. And we get X is less than or equal to 7. Now again, because this is a and statement, we're going to combine these together. So you're going to take the smaller value, 1 is less than X, which is less than or equal to 7. We have this answer. And go ahead and graph this, and let's see if you have the correct graph. Okay, let's see how your graphs matched up. So we have our values 1 to 7. Now you'll notice with compound inequalities, you're probably going to have more than 5 numbers sometimes, which we already have. And that's okay. I always said you had to have at least 5 values. You can always have more, okay? And since 1 and 7 are even numbers, obviously we have to actually count by ones here. So we have an open circle at 1 to represent the less than. We have a closed circle to represent the less than or equal. And our values go in between. So this should be our proper answer for number 5. Let's go ahead and look at number 6. Whoops. Try that again. Okay, this is going to be a different way of looking at an and statement. Now we talk about how our and statement should look like this at the end. Let's look at what happens when we have a multi-step problem where it's similar to this at the beginning. Negative 50 is less than 7k plus 6, which is less than negative 8. Negative 50 is less than 7k plus 6, which is less than negative 8. So what we're going to do is essentially we're going to solve outward. So we have all this in the middle and we want to isolate it just down to k. So we're going to simplify, and whatever we do to the inside, we have to do to both outsides. So if I subtract 6 from here, I also need to subtract 6 from the left and the right. Remember, when you do something to one side, you must do it to the other. And in this case, when you do it to the inside, you have to do it to both outsides, okay? Keeping it even and balanced. From there, negative 50 minus 6 is negative 56, which is less than 7k, which is less than negative 8 minus 6, which is negative 14. Go ahead and solve the rest of this problem and check back with your answer. Okay, from here you should have divided by 7 on all 3 parts. And you get an answer of negative 8 is less than k, which is less than negative 2. Like such. Okay, and if you haven't already, go ahead and pause here and make your graph as well. Let's see what your graph should look like. So because we have some even numbers, we're going to go ahead and use that to our advantage so that we can do some less numbers. So starting with the smallest number and working my way up. Now this is only 4 numbers, so I'm going to go ahead and grab one more and go up to 0. So I have at least my 5 numbers. Then I'm going to follow my information. So I have an open circle at negative 8, an open circle at negative 2, and a line to the middle to connect them. And that's how we could do number 6, which is slightly different than number 5 for an and option. Okay, let's look at number 7. So number 7 is an or statement. So when we have or statements, you're going to have 2 different problems and you're going to solve them separately. Okay, similar to number 5, where we had 2 separate statements, but because this was, because this was an and, we ended up combining it at the end. But because it's an or statement here, we will not be doing that. So go ahead and solve the first one and the second one separately, completely separate, and graph your answers and report back to see how you did. Okay, hopefully you paused it and let's see how you did. So the first thing we do on the left problem is add 1 to both sides. So I get negative 10a is less than, and this actually goes down to 0. Okay, remember, anytime something cancels out, it is 0, but if it's by itself, you have to keep the 0. You can't completely ignore it like we do over here on number 7, on the left side of number 7. Then we want to divide by negative 10. Now, we haven't experienced this yet, but what happens when we divide with a negative number? Hopefully you're remembering that when you divide by a negative number, your sign changes to the other side. So now I have a is greater than 0. So again, because we divided with a negative number, that inequality sign had to change. Now let's look at the other part. So over here, we're going to subtract 10 from both sides, giving us 3a is less than or equal to negative 15. And then we're going to divide by negative 3, or sorry, not negative 3, positive 3, apologize, misspoke. And because it's positive, we will not change the sign, so a is less than or equal to negative 5. And again, this is an or statement, so we want that whole thing. And then for our graph, starting at the smaller number and working our way up to make sure we cover all our values. We're going to have a closed circle at negative 5, and a is less than negative 5, less than or equal, so it goes to the left. And a is greater than 0, so we have an open circle at 0, going to the right. And that would be our answer for number 7. And those are all the notes for today. Good luck with your assignment, and ask questions when you need.